Concept getters, I hope everything is going well and that the year so far is going great for you, that you are passing and distinctions also seem more possible and more possible, right? I want us to do this specific question, but this one is one amongst the three, right? So I'm going to go straight to the concept. That box, that mini box here that I'm closing right now, I'm going to go there and I'm going to say, I'm going to explain what's really going on with these type of questions. It's three exponential equations. This video is just part one. And then there's going to be part two and there's going to be part three until you understand all equations that are based on exponents, right? So let's go to this concept here. You can see this. You can see. Come on, you can see, right? You can see. Guys, we have three types of exponential equations, as I said. First part is the one that I'm going to do right now in this video, which is where we have, let's say, just a sum or just a question where you only have to simplify one part and you simplify the other part until you get two parts with the same base and then you equate the exponents. That's the first part. That is this one, right? The second type of exponential equation is where now you will have two terms on the exponent. You can see here, if I enlarge, you can see you have two terms on the exponent, and then you also have a power that consists of the same exponent that will be the same as one term in the other exponent. So basically here you have x and then you have x, and that x, bear in mind, it does not have a coefficient. Clear? So this type of question is where you just take out a common factor. You will see on the next video. And the third one is this one now that is written in black, right? The third one is where now the base will be raised to an exponent of a variable. That variable will have a coefficient of 2, right? And then again, the same base will have its own term here that will be raised to an exponent of a variable that doesn't have a coefficient. So, and then there will always be another term. Sometimes there will be another term, sometimes there won't, but then there will be another term which is just a constant on the other side of the equal sign, or sometimes it's not going to be on the other side of the equal sign. But just know that what differentiates this from this is that this one has a coefficient, this one does not have a coefficient, it is just added. So you'll see when we do both of them in the other two videos, right? Which is going to be part 2 and part 3. But just know it's only 3 types. This type, right? And then this type and this type. And all are different, or their approaches are different. But this specific video right now, guys, is only going to be based on part 1. So let's check how we do part 1, okay? So we're going to go back and say, right? So now when you look at this, guys, you can see that you can already see that the basis of each power, right, can be changed to a prime base. So let's change it. I'm going to say 3 to the exponent for x multiplied by. When you change 9 to a prime base, it's going to be what? 3 squared, right? And you're going to have x plus 2. Then when you change 27 to a prime base, it's going to be 3 cubed, which is going to be to the exponent x, right? All over, right? And then you have 3 to the exponent 2 minus x multiplied by. Now 81, when you change it to the prime base, it's also going to be what? It's going to be 3 to the exponent 4. Then you're going to say x minus 1. Then you say equal to 27 in itself. When you change it to a prime base, it's going to be what? 3 to the exponent 3. Then you close. That 2 on the exponent is going to be here, and it's going to multiply the 5 outside. Clear? Then when you solve now, obviously when the prime bases are the same, you just add the exponents. But then if you have brackets, the exponent inside the bracket will multiply all the terms outside the bracket. Like with this one here, this will multiply this and this. Do that make sense? So I'm just going to be like 3 to the exponent 4x, right? Multiplied by 3 to the exponent 2x plus 4. Because 2 times x is 2x, 2 times 2 is 4. and then I'll see multiplied by 3 to the exponent 3x all over 3 to the exponent 2 minus x times 3 to the exponent 4x minus 4, because this will multiply this and then we'll multiply this as well. 4 will multiply x and multiply -1. And then we will have equal to, now the 3, the 2 and the 5 will multiply each other. So 3 times 2 is, come on guys, 3 times 2 is 6, and 6 times 5 is, come on guys, it's 30, right? So I'm going to have 3 to the exponent 30. Now, there are laws of exponents. One of the laws of exponents is that when we multiply powers of the same base, we add the exponents, right? And then when we divide powers of the same base, we will subtract the exponent of the denominator from the exponent of the numerator. So now, basically what this means is the exponents from the denominator, when they go up, they will change their signs. If it was negative, it's going to be positive. If it was positive, it's going to be negative. And the exponents in the numerator will just add each other. Clear? So when I do this, I'm just going to be like, oh, which means my next step will just be 3 to the exponent 4x, and then I will add 2x, I will add the 4, and I will add the 3x, right? I'm just adding the exponents. But now when it comes to the exponents of the denominator, they will all change their signs. So the 2 was positive. This 2 here was positive. Now it's going to be -2. And the x was negative. Now it's going to be positive, right? And the 4 was positive. Now it's going to be -4x. And then the 4 was negative. It's going to be +4. Then I'll just say equals to 3 to the exponent 30, right? Now, the next step is just to group up the like terms, right? I will be like, oh, 4x and 2x and 3x and x and -4x. When I add all of them, they're just going to give me 6x. So I'm just going to be like 3 to the exponent 6x, right? And then when I check the 4 and the -2 and the 4, when I add all of them, they're going to give me +6. So I'm going to be like +6 is equal to, right, 3 to the exponent 30. Now, when you are done with the exponents, right, guys, when you are done with the exponent, when you're done with the power, like when you have 3 to the exponent 6s plus 6 equals to 3 to the exponent 30, now that the bases are the same and the exponents are simplified, you can just drop down the exponents. Every time when you have powers of the same bases on either side of the equal sign, right, you can start equating the exponents and drop the base. Do that make sense? So you're just going to be like, therefore, I'll be left with 6x plus 6 is equals to 30, right? And then you transpose the 6. So I can continue here, guys. Can I continue here? I will just drop the 6. I'll just say, I will transpose the 6. I'll say 6x will be equals to 30 minus 6, which means I'll have 6x is equals to 30 minus 6 is 24. Then I will divide by 6 and I will divide by 6, right? And then now I know 6 cancel 6. I'll be left with x is equals to 24 divided by 6 is 4. And I would have solved it. Yippee! So in order to check if this is actually the case, you can always test by substituting this solution onto x at the top there. Like just substitute it onto x, write the whole thing on your calculator, type it out, and then substitute x with 4 and check if your answer will give you this. Or check the answer, write equal to and find the answer, and then type this out and check again if the answers are the same. If they are the same, then you're right. If they are not, then start it again and check which law you did not apply correctly. Does that make sense? So this is one type of an exponential equation. Now, click on the description. Just go to the description, go down there, you'll see part B, all right? Once you see part B, you'll see part C, and just like that, all right? Otherwise, remember, guys, remember, we are here, and we do this, we go like, and we go like, right? And we're gonna be like, subscribe, and remember to share, and remember to comment. Tell me what's not, and what would help you, and do that make sense? Let's engage. Tell me which other question or concept you would like me to break down. You know what I mean? And remember to share to others so that they can also find math easy, and subscribe so that you don't miss out on the next videos. And most importantly, please pray for my handwriting. Ish.